Okay.
Okay, well, that
Should be
really-
set, thank you.
I'll go to your funeral.
All right, for those of you listening at home, howdy. We're going through notes on the next worksheet. This is worksheet 1B, geometry worksheet 1B. Everybody tune in? Okay. We're talking about a shape that has 3 levels. All of them are parallel. That's what these arrows that are pointing the same direction mean. If you have the same number of arrowheads in here, this, it means they're all parallel to each other. Now, I've given you a couple of measurements. From A to C, it's 6 inches. From B to D is 4 inches. From C to E is 18 inches, and D to F is unknown. Any brainstorms as to how to find X? This missing distance here. I'll show you if you don't, but give me.
12.
As a matter of fact, it is 12. How do you get that?
Dang.
You like reduce the 6 and the 4 to 3 over 2.
Okay.
Oh.
There are at least 2 ways to do it. So 6 compared to 4 reduces to 3 to 2. Okay.
And then you do that with the 18.
So 18 to X reduces to what?
3 over 2.
It should be the exact same. So how do you do that? So what are you dividing by?
3. No, 6.
6. Or if I go the other way, 6 times 6. So, times 6, 2 times 6 is 12. Yeah. That was, we're just sort of feeling our way in the dark, but that was correct. Now, is there a guaranteed way to do this? Yes, and I'll tell you in about 5-10 minutes. What I do want to highlight is that there are go ahead and draw this. Underneath this, label it A, B, D, C. What I did is I surgically removed the top layer, put it here. And then the bottom, do this. Whoops, sorry, my fault. Not that is. Label it A, B, F, E. Last week, we covered a word called similar. Whoa. Similar.
We gathered.
Oh, wow.
Is that what it said?
What is similar? My brain is doing something weird. What does that mean? Similar. Go.
They're the same shape, but not the same size.
Right. Same shape. And I would say not necessarily the signs. Same size. They could be, but usually not. One is usually a magnified version of the other. How do you tell if 2 things are similar or not?
You asked your teacher.
Nice try. On a test, that's not an option. If you have 2 shapes that are similar, that's just like a mirror, like a magnified image of another under a magnifying glass, what could you tell me about their angles compared to each other?
They're same.
They're the same. The angle, there's another word for same. Something where same shape, same size. Equal size, bless you. And it starts with a C. Go. Congruent. The angles are congruent.
What?
A little too much talking. What about size? I need everybody focusing up here, please. Please don't get too much on my nerves today. Thank you. And that's one way to do it, gentlemen. To immediately start talking to each other when I just told you to pay attention up here. the sides? You have two shapes that are, one is a magnified version of the other. Are the sides identical? Maria?
What was the question?
If you have two things that are similar, are the sides identical?
Like in shape or in size?
Both.
No.
No. What are they though? Let me give you a quick example. If you have two shapes that are similar, they have the same basic shape. One's a magnified version of the other. Let's say this is 3, 4, 5. This is 6, 8, 10. The sides are not identical, but they are what? Not congruent, because congruent means identical. They correspond, you're getting close. Like 3 corresponds to 6. Corresponding means how they match up in position. But there is something about it, go.
Similar?
You're getting close, whoa, hello.
Whoa.
Similar shapes have what kind of size? Starts with a P.
Parallel.
Not parallel, these are not parallel.
Polygon.
No, don't just stab in the dark.
Proportional.
What is that?
Proportional.
Write this down. Sides are proportional. Remember what I said? The angles are the same, but the sides are proportional. Proportional just means they got bigger or smaller by a certain fraction. You know, they're twice as big or half as big or whatever. I'm getting ready to move people. Please cooperate with me. Okay. It doesn't have to be unpleasant this hour, but it can be. Over here, the sides, are these similar?
Yes.
If so, prove it. By the way, all you have to do is prove one of these two. One of these two. For similar. You don't have to prove them both. If you can prove that all the angles match, or if you can prove that all the sides are proportional, you're done. Yeah.
Well, the sides are, like 6 to 4 is, wait a minute, oh, no, I'm right, it's the same one.
Yeah, and by the way, visually up here,
6 times 3 is 18.
do you notice I did not draw the lower one by itself? I drew the one on top and then the whole one. So what happened is this entire big one is a magnified version of the one on top. It's just stretched. Can anybody prove that those are similar? You can either look at the sides or you can look at the angles, whichever one is easiest. One way to prove it is to prove all the corresponding angles are identical to each other. So here's a question for you. Is the upper left identical to the upper left?
Yes.
Prove it.
Because
There's kind of an obvious reason.
upper right is identical to upper right.
Not necessarily, we haven't gotten
Oh,
there
they're
yet.
both
Go.
right.
But it's 3 times bigger.
The angles are,
Or the sides.
the sides are,
Yeah.
and we'll get there in a second. Yes, go.
They're both.
They're the exact same angle.
That's right.
Angle A,
Oh,
angle
that's
A.
so obvious.
See? So you got one. Is angle B congruent to angle B? Johnny?
Yes.
Yeah, the exact same angle. By the way, are these two the same size, A and B?
Yes. No.
No, but everybody look up here what I'm about to do. You see how I marked these with one arc? I'd like to mark these with 2. It might be a right angle, but I'm not sure, so I can't mark it as one. It could be 91 degrees.
Well, how
I
about,
could if I were, but it's not necessarily.
wait, you could if you
In
were.
other words, she's asking, is this 90 degrees? Not necessarily. I can't say that for sure. So it could be 89, could be 90, could be 91. It doesn't really matter. Down, lower, left. This is a little tougher. Is the upper angle D the same size as angle F?
Yes.
What would you say, just your instincts? Catherine?
What was the question?
Okay, welcome back. Is this upper angle D the same size as this angle in your instance? Yes, I agree. Eric, would this upper angle C be the same size as angle E?
No.
This angle here and this angle here.
Yes.
Don't just say it because John is saying it. Here's a hint. Suppose you have two lines that are parallel, like absolutely even, and then you slice them with one line. Are these going to be the same size? Yes, because it's the same tilt. If this thing is cutting at a 40-degree angle, and these are absolutely even with each other, they have to match. So the answer is yes. This matches this, and by the way, I'm going to do 3 arcs here. I'm going to do 4 arcs here. Did I not warn you?
Yes, you did.
Okay. Rob, I might be moving to the back.
Okay.
Grab a chair, move off to the side of the table.
This one.
There really isn't room to squeeze you anywhere else. I'm not looking for excuses or complaints.
I'm not excusing nothing.
I'm not looking for comments. I'm not sure what's rocket science about this. If I move people for talking, then continuing to talk is an extremely unwise move. Yes?
Yes.
Anything hard to understand about this? I'm not sure what's gotten into some of you today, but it's gonna stop. Again, I like math class to be lighthearted, but if people just take advantage of that and run all over the place, I'm gonna come down on you like a load of bricks, because I have to. I'd rather not. The only other course is I can keep you in with detentions and scrubbing the walls here for a while. Clear?
Yes. Next question.
Is it about the lesson here? No, don't, until after class. Then I'd be happy to answer any questions. Clear so far? We've proven that this and this are similar. That means that all their sides are proportional. How big is AC, Isabel? Look in the original problem. How far is it from A to C? 6. How far is it from A to E?
It is 24.
Yeah, how do you get that?
18 and 6.
Right. You notice this is 6, this is 24. You had to add in order to get it, but that's fine. Take over Mary. How big is it from B to D? 4. Now, I need a formula here. It's going to be a little weird. How long is it from B to F? 4 plus X. This is technically the way you'd solve it. I will show you a shortcut in a few minutes. But, you remember how to set up proportions? The beginning of the year, chapter 9. What is a proportion? What's the definition of a proportion? 2 equal whats? Yeah, Jacker.
2 by 2, something equals something else.
Exactly. And what 2 something? What kind of numbers? Negatives, decimals?
Do they have to be positive or should they matter?
They're usually positive. In shapes, they definitely are. And what kind of numbers? What's their appearance like?
Whole?
Actually, they're not.
Fractions.
Fractions. Proportions are 2 equal fractions. In other words, 2 over 3 equals 4 over 6. I just wrote that off the screen for Jack, sorry. But you get the idea. Any 2 fractions that are equal, that's a proportion. So, can somebody set me up a proportion here. Galene. Compare the top to the bottom. Give me a fraction, like the left-hand side. Give me a fraction. 6 over, yeah, equals what? Match the other one. 4 for 4 plus x. Okay, math people. You had a worksheet on this when I was gone. Do it. Brendan, take over. How do you solve for x? There are at least 3 ways you could do it.
Divide by x, no. Minus x, nope, oh my goodness.
Right, it's buried in the bottom, which is making it difficult. There is a way.
You do the multiply by those, nope, yeah.
Kind of. You're getting closer. Go.
Cross multiply.
You can cross
Oh,
multiply. When it's over an equal sign, you can cross multiply. Do it for me, Brendan.
me?
Yeah.
Oh, you have,
So what times what? What two things?
24 times 4.
Okay, we're gonna write that for a second. 24 times 4 equals what times what?
24 plus 6x.
Well, yeah, but 6 times what?
4x.
4
4 plus
plus
6.
that. Let me see where they came from. It's just plain old cross multiply. Rob, take over. Go ahead and do this. What's 24 times 4?
1 second. 96.
Yes. Equals, and what do you do here?
24 plus 6x.
Yeah, 24 plus 6x. Andy, first of all, stop turning around, or I'll see you after class. Andy, take over.
You put 24 on the other side.
Ah,
Subtracting.
subtract. What's 96 minus 24?
It's 92.
Okay, equals 6x. Keep going.
Divided by 6.
What do you get?
12.
12. And that's exactly what we predicted. That's the technical way to do it. That's the long way to do it. That will always work, by the way. There are 2 ways to solve problems like this. Let me write this down. There are 2 ways to solve similar shapes. Side to side. I'll explain what that is in a second. And the second is called part to whole. Side to side and part to whole. Again, I'll explain that in a moment. What do we mean by side to side? Let's try this. Draw a new shape like this. This time I actually will mark these as 93 angles. These are not, obviously. Give me a thin layer on top, a not quite so thin layer next, and then leave it like that. And mark these all with a single arrow so that they're all parallel. Okay. I'm not going to give letters this time because there'd be so many of them, but I'm going to give you some numbers. This would be 10 inches, 12 inches, 15 inches, 25 inches. 2 inches, 3 inches, 5 inches, 1 inch, X, Y. Actually, I take that back. Hold on a second. Leave the 12 as it is, but erase the 15 and 25. Those are actually a different problem. I'm going to call this A and B. I want you to find them. They are actually a little small in there. They're not the numbers I had. That was actually from a different problem.
Bless you.
Go ahead and draw this. If you haven't already, draw it.
Draw what? Oh.
What I have been drawing for the last 2 minutes.
Oh.
Mr. Cochran? If both of them are 90-degree angles, then how is one 2 inches and then one 1 inch?
This is not a 90-degree angle. So when this is
Oh.
tilted out, it makes it go longer.
Gotcha.
All the ones, by the way, that is a point. Look on the right-hand side. Can anybody guess what the angles are next to X and next to Y?
Right.
They have to be right angles, correct. These are also right angles. And the ones on top are too. So, how do you set them up? Side to side and part to whole. Here's what I mean. First, side to side. All this means is compare the left side to the right side. This means that 2/1 is equal to what? Go down to the next layer. Go. What's the next layer? The top layer is 2/1. Go to the next layer down. 3 to X, good. And then one more, keep going. From 5 to Y. That's side to side. That should give you the values of X and Y when we get there. The second thing we'll be doing is part to whole. This is a little harder to see. It's not as easy to see. A lot of people assume it was 2 goes to 1 as 10 goes to 12. It doesn't work. You can't really mix and match. Here's how part to whole goes. This is the first layer. This is the second layer. This is the third layer. It's a little hard to see at first. Watch this. 2 does not compare. It's sort of like some people say 2 goes to 12 as 3 goes to A, and that actually does not work. Good question. Right back. I'm not going to go to, in other words, it does 2 compared to 12 as 3 compares to A. Say, well, the left goes to the first bottom, so the left goes to the next bottom. No. 2 goes to 12 as, how much is this? Down to here,
3.
total.
5.
5 goes to A. 2 goes to 12 as 5 goes to A. See the difference? In other words, I'm doing one layer, part to whole, another layer, the whole thing, and then the third one will be even further. So the part to whole is 2 to 12 equals, what was the first fraction? John.
Huh? Oh.
So left to bottom, what's the bigger left to the bottom? Total.
5.
5 to the bigger bottom.
5.
And then give me the largest one, all the way down.
10.
10 over what?
B.
Exactly. See a difference? I'm not just going little left to bottom, little left to bottom, little left to bottom, and it doesn't work. The proportions don't work. But you look at these as they're bigger and bigger versions of the same shape. That's what I need. I need similar shapes for this to work. So 2 over 12 equals 5 over A equals 10 over B. That should work. Now, let's see if we can actually get this to work. Let's erase some of this so I have some space. Can somebody actually solve those? I've got the 2 over 1 equals 3 over X equals 5 over Y. You can take either X or Y first, it doesn't much matter. Can somebody try X? Just ignore the 5 to Y for now. Therese, help me out. 2 over 1 equals 3 over X. How do you solve that? Yeah, cross multiply. What do you get so far? 3. Go ahead and solve. Yep, what do you get? X equals 3 over 2, or if you like decimals, 1.5. That's That's how big this is. 1.5 inches, 3/2 inches. Can somebody do y? Eric, help me out with this one. How do you get y? I'd love to cross multiply, but what do you cross multiply with? Can I do these two? Try cross multiplying it, see what you get.
3y equals 5x.
Right, 3y equals 5x. Would that solve? Why not? There's an obvious reason why not. You're right. What's wrong with that?
3 doesn't run 5.
They don't, but there's something even worse. Like, I'm trying to get y by itself. Like, let me write it. 3y equals 5x. And you want to get y by itself? You can divide by 3. Does that tell you what y equals?
No.
What's wrong?
We don't know what x is.
Exactly. This is unknown. If you have two variables in the same problem, don't bother. But they said that all 3 of these matched. You may have any idea which 2 fractions would be good to use. I want to find y, and I want to find y in a way that works.
Couldn't, you use the 2/1, but why couldn't you use the x if you just found x? and
Oh,
used it?
if you plugged x in, you could. I'm just saying it might be a little awkward because it's going to be a fraction and there are types of fractions. Could you do
plug-
it? Yes.
Could you plug it in once you get 5x equals y?
Yes, you could. It'll still be a mess because it's 5 times 3/2, it's 15/2. Would it work? Yes. It's a bit of a pain in the neck because you'd be dividing by fractions twice. So can you do it? Yeah. But if you match it up with 2/1 equals 5/y, it's going to be a lot faster.
Couldn't you do, plug it in and solve that fraction and get 6/3 and put it equal?
Plug which one? I'm sorry.
Put the through x, plug in x.
Yeah, that's what Andrew was saying.
But
Could you
then-
plug x in and use
No,
it?
but then divide it, have 3 divided by it, and it's 6/3 and then equal it to 5/y.
Like if you, simplify it first, you mean? So 3 divided by 3/2, and that's multiplying by the reciprocal. That actually turns into 2.
Yeah, but could you do it 6/3 and then cross multiply?
We're using 6/3.
Cause that would be 2. Like, could you put 2 in a fraction and 6/3?
What is 6/3?
2.
2,
But could
right.
you cross multiply it well in fraction?
Oh, I'm saying, well, here, what you and Andy are suggesting is, could I plug, once you have the x, could you plug it in and have it work? The answer is yes. It takes a little longer. It would look like this. Once you have numbers, it is pretty good to go. Now, that's something I will admit is kind of sneaky. Multiply by the reciprocal, these cancel. 2 equals 5/y, which is actually not, and then you're thinking 2/1, is that what you're saying? Make it a fraction? Then the answer is yes. However, look what would have happened if you had used the fraction in the first place. The exact same one, and you skip a step. In other words, you'll get the right answer doing that. It'll just be one extra step, which is no evil about it. So you get 2y equals 5. Give me the final answer. Andy,
What?
solve
5/2.
5/2, or 2.5. That's this missing side. Does this make sense? Notice we have not found A, and we have not found B.
I have a question.
That's gonna take something else. Is everybody, any questions just on this so far? Go.
Can I go to the bathroom?
If you heard that, yes.
Okay.
Everybody clear? Now I want to try the part to whole. Let's erase some of this stuff so I can get some space. Again, it's a little, it takes some focus here. That's actually why I was nagging you about focusing. Because if you scatter, this is going to be really, really hard to understand. Once you follow it, again, so suppose you have these 2 layers. This is layer 1 to layer 1. Layer 2 to layer 2. You don't take just the middle part by itself. Then layer 3 to layer 3. This is part to whole. Okay? In other words, if you're going down to the middle layer, you've got to go all the way to the middle layer, not just a little piece of it. Let's try it. We've got 2 over 12 equals 5 over A. Equals 10 over B. Somebody step me through how to do that. Like if that's all you have, like you'd have to find these by looking at the picture. But once you do, how do you solve it? So it's a 2-step process. 1 is get the fractions proportioned, and 2 is solve. How do you do it? Maria, take over. Is there anything you can do to any of these fractions first?
You could reduce the first one.
Yeah, what is it?
1/6.
1 over 6. That, by the way, will make your math easier. And you might even be able to do some of these in your head now. You can by definitely cross multiply. But what are you multiplying by, Rob? What are you multiplying by? Go with me. 5. If these are proportional, you do the exact same thing here. Tell me what A is. 30. Now try it up here. What are you multiplying by? Do it.
60.
You're done. You just found A, 30 inches, and you just found B, 60 inches. Now just to show you, you could have done 1 over 6 equals 5 over A, cross multiply, which actually is nice, A equals 30, 1A is 30. And you could also match the 1 over 6 to the 10 over B. And that cross multiplication is pretty easy, it's easy. Make sense? Yeah.
How is that tiny little part of it, so if you overlaid like A onto B, you just like put it down a little bit, how would that tiny little part that B has on it be twice the size of A?
This thing right here, that's just because I drew it that way. Yeah, this thing probably has way more of a tilt in real life. It probably would have gone way out like this. That's just because I was a sloppy artist on that one. But yeah, as long as you're getting bigger and bigger and bigger, the picture will work.
Okay.
Does that make sense? Grab your worksheet. I want to go through a problem with you.
How about not? Because I kind of have to work on
Hold
it.
on. You're not contributing to a problem. Contribute to complaints. Just a moment, please. Yeah.
How come it's not like actual like triangles?
Oh, well, number 1, here's how you do it. You're gonna have to rotate your paper like this.
I don't think that's.
Wait, why?
Here's the top of the paper. Rotate it to the left a little over a quarter of the way, so that this the shortest little arrow is on top. It'll look like one of these. The arrows keep going. You can ignore the arrows that keep going. All you're looking at is the layers. So that is, these things are actually called trapezoids. There's a top base, a middle base, and a bottom base. Now you'll have to look at it right side up to see what the numbers actually are. What would you say for number 1? Are they talking about side to side or part to whole? Side to side. That's the only thing you need for number 1. Proportionize the side to side. So can somebody give me a proportion for number 1? How do you set it up? Me or go me? What fraction equals what fraction? And there are actually 2 ways to do it. As long as you put corresponding parts corresponding.
What?
In other words, there's 2 different ways to set up the proportions, and both of them work. 9 goes to 9 goes to 12 equals, so 9 over 12 equals what? 15 to x, 15 over x. And then cross multiply and you're done. Does that make sense? You could also do 9 to 15 as 12 to x.
Wait, why is it different? I thought it was 9 to 12.
9 to 12 is the easiest.
Oh, so.
9 goes to 12 as 15 goes to x. Make sense?
Yeah.
That's the side to side, and that'd be by far the easiest. Be careful, don't do 9 goes to 12 as x goes to 15. That's going backwards on the second layer. Make sense? So make sure that the small parts are matched up and the big parts are matched up in your fractions. Okay. Number 2 should be similar to that, no pun intended. Number 3 is actually side to side. They're just trying to be a little more clever about it. Do you notice how 2 goes to something as they don't even tell you the left-hand side?
Which one are we on?
Number 3.
Oh, I thought we were on number 2.
Number 2 is done almost identically to number 1. Look at number 3 just for a second. Does anybody see the way out of that?
No solution.
Because it's kind of wrong.
Is it x plus 8?
I'm sorry?
Is it x plus 8?
Look at the right-hand side. The left-hand side, can anybody give me the left-hand side of the top layer? 2. Can anybody give me the left-hand side of the bottom layer just by itself? 4. How do you get that? Subtraction. Now you can do part to whole. Or side to side, rather. Yeah. There's another way you could do it. They're looking for the entire right side. So what's the entire left side? 6. You could do, by the way, is there something that would match up the bottom? What's the left side of the bottom again? You did it earlier. 4. The bottom is 4 to 8 as 2 is 2. 2, they didn't give you the right-hand side of 2, but they did give you the entire right side. So I'm just using the bottom. 4 goes to 8, left goes to right, as 6 goes to x. Yeah, they want the entire thing for x, not just the top little piece. Yeah, question?
Instead, could you do 2 over 4 equals x minus 8 over 8?
Oh, if you want to just get the right-hand side of the little top part? 2, yeah, if you want to do that, it would be 2 goes to 8 minus x as 4 goes to 8. The 8 minus x is the little itty piece on the right. The whole thing is 8, or 8 plus x, yeah.
Or would it be x minus 8?
Yeah.
If you want to find out, actually, oh, that would be actually, yeah, x minus 8, my bad. Did I say it backwards?
X minus 8.
Yeah, it's x minus 8.
Wait, what is?
Let me say it again.
Oh my god.
I would not recommend doing this, by the way. Different people's brains attack these in different, by the way, that's a perfectly legitimate way to do it.
What?
Okay.
I'll give you 3 different ways to do this problem. You can go upper left, upper right, lower left, lower right. That would be kind of challenging on this one because they did not give you the upper right. That little itty bitty piece to the right of 2. It's actually x minus 8. That's kind of a tricky to see. If you call that whole right side x, that whole right side is pretty big. That's x. Subtract 8 and you get the little right hand side piece. So x minus 8. So 2 goes to x minus 8 as 4 goes to 8. That make sense? That's the only way, that's one way to do it. Another way is you can do entire left to entire right equals lower left to lower right. I think that would probably be faster. So 6 goes to x as 4 goes to 8. And that would probably be fast. Clear on that?
So that'd be 4 divided 4. It'd be 4 over 8.
Yeah, write them both as fractions first before you do any division. And before you do any cross multiplication. Just write them out as fractions first so you know which one you're looking at.
How do you do 13, 14, 15, and 16?
Whoa, hold on. We're not there yet.
Well,
For now, there are a few of these I'd like you to skip.
Oh, I would love to.
First of all, the part that I'm assigning right now is not due tomorrow, remember it's due Wednesday.
Okay.
Circle the following. Here are the ones that are going to be due on Wednesday. Number 1, number 2, number 3, number 4, number 6, 7, 8, 9, 10, 11, 12.
9,
skip number 5 and skip the back page, basically.
What if you did number 5?
5 we have not covered out of here. I would say erasers.
So,
Does that make sense? Number 5 is tricky because it's actually not similar triangles.
Yeah, I don't know what's wrong with it.
So we're gonna cover that in tomorrow's notes.
I think the
So
answer
skip
is
number 5 for now, and
10.
skip the last page, although I can give you a teaser for the last page.
I'm good.
Do you remember the formula that always works on a right triangle?
4.
N, 180, N minus 1.
A squared plus b squared equals c squared. A squared plus b squared equals c squared. I'll cover that tomorrow as well. That's called the Pythagorean theorem. There's in any right triangle, Pythagoras discovered a formula that works. A, B, and C, where A and B are the short sides and C is the big side. He found out that A squared plus B squared is always equal to C
Wait,
squared.
who did?
Pythagoras,
Is
famous
he, like,
mathematician.
Egyptian?
Greek.
Oh.
Greek. I can show you his name actually. Pythagoras. It's in Greek. It's not in hieroglyphics.
Oh, wow, that sounds quite the name.
It's in Egyptian.
It's in Greek.
Um,
Okay? Anybody know which ones to skip, by the way? Skip number 5 and skip 13, 14, 15, 16 for now. If you want to try 13 through 16 using the Pythagorean theorem, you're welcome to. Just might be a little easier to waste those notes. Okay? And again, these are not due tomorrow, they're due Wednesday. And then Thursday, I'll have the rest of them due, 5 and the last page. Okay?
it's 3 o'clock.
It is about that time. So please stand. Let us pray.
This makes sense.
In the name of the Father, the Son, and of the Holy Spirit. Amen. Glory be to the Father, and to the Son, and to the Holy Spirit. As it was in the beginning, is now, and ever shall be, world without end. Amen. In the name of the Father, and the Son, and of the Holy Spirit. Okay, Andy, you're up.
Oh, the button. Mr. Conklin, can you tell me how to do this? Because
I think you like.
I'll wait for him. There's the thing. Oh, yes. Should I stop it? Yes.
I don't think Jack.
Bye, Jack.
Bye, Jack.
Where are you? I'm gonna murder you.
Okay, let's not say that. This is gonna be on
Well, I
YouTube.
am.
We are a
I
safe
will slap
school.
in your face.